Okay, this particular video is going to cover a 2007 question 2 and how to carry out a completely randomized design. But before we get into that FRQ free response question, I want to go ahead and talk about the recipe of success that goes with it, because there's some important things to talk about. I know, while not required, being able to set up one of these diagrams, and you definitely need to be able to interpret it, is very helpful in understanding what you have to show or what you have to write about. The diagram by itself is not sufficient, but we need to talk about initially about random allocation or random assignment. You would start off by drawing that. You talk about your treatments. You're going to have at least 2. In this case, I have 3. You can have an infinite number, but in this, you have to have at least 2 because it's an experiment. So you have to have 2 for, and then you randomly assign to either treatment 1 or treatment 2. And at the end of time, we're going to compare results. So that kind of tells you the steps. So we started off with random assignment or random allocation, which is where we impose the treatments. And we're going to explain how we do that. We could be placing the names in a hat, mixing and drawing. We could flip a coin. We could assign a number and place in a hat. We could use a random number generator. So that's the way you would do the random assignment of the treatments. That's the way you do this first part. So then we need to talk about what is being assigned. We need to examine the treatments, okay? The treatment itself is the explanatory variable. Very important to know that. That's the explanatory variable. That's the input, all right? Then we need to identify what we're comparing at the end. That is the response variable. This is the output, all right? What are we interested in? So this right here is the input. It's your treatments. Your output is what's going to be impacted. And this would be a single variable. Even though we have 3 treatments, it's only one single variable here. I'm going to look at a 2 variable situation here, right here. So with a multivariable, here I'm randomly assignment to the first treatment. Then I randomly assign, and so here I have 1 treatment with 2 levels. Then I randomly assign to a second treatment, and this treatment has 1, 2, 3 levels. All right. So, and at the very end, we're going to compare our results. And the only reason I'm doing this is just so you kind of get an idea. Well, if I go 2 times 3, I end up with 6. So I actually have 6 treatment levels, and you can sit there and go 1, 2, 3, 4, 5, 6. But once again, this is one variable. This is my second variable. And these are the input variables. We only have 1 response variable, okay? All right, so let's go ahead and by the way, we will have an assignment that makes this even more clear on how this works, but there will be an assignment that helps make that more clear. So let's look at this 2007 question number 2. As dogs age, diminished joint and hip health may lead to joint pain and thus reduce a dog's activity level. Such a reduction in activity can lead to other health concerns such as weight gain and lethargy due to lack of exercise. A study is to be conducted to see which of 2 dietary supplements, glucosamine or chondroitin, is more effective in promoting joint and hip health and reducing the onset of canine osteoarthritis. Researchers will randomly select a total of 300 dogs from 10 different large veterinarian practices around the clinic. So around the country. We have 300 dogs. All of the dogs are more than 6 years old, so we're controlling for age, and their owners have given consent to participate in the study. Changes in joint and hip health will be evaluated after 6 months. So they're telling me the joint and hip health, that's my response variable. So here's my response. Up here, this is my treatment groups. What would be an advantage of adding a control group in the design of the study? Remember, the control group provides a baseline. I always recommend you start off with the definition. Adding a control group to the study will allow researchers to determine whether the changes being observed were due to the treatments or due to variables of the study. Notice that's not in context. That's only a definition All that did was tell people that I know something. I don't get any credit for that because it's not in context, but it sets the reader or the grader to go, you know what, they know something about this, and I'm likely to have a more favorable outlook if there's some of their vocabulary or their sentences aren't quite right. So for instance, as dogs age, it's reasonable to assume that their joints will deteriorate. They don't get better, that's for sure, as you get older. By having a control group, we will know whether or not the treatments retarded the deterioration or slowed the deterioration. In addition, a control group would allow us to determine whether joint pain might be attributed to weather. For instance, joints are typically less painful during warm months. So we wouldn't know if the dog's joint pain responses were due to weather or the treatment if there were no control group. So we have a couple things there. As they age, their joints are going to get worse. The question is, did they get worse if they take the medication, do they get worse at a slower rate or a faster rate? Also, real quickly with this, I would like to say that in this particular case, we actually have essentially 3 treatments: glucosamine, chondroitin, and the placebo. Okay. Assuming a control group is added to the other 2 groups in the study, explain how you would assign the 300 dogs to these 3 groups for a completely randomized design. So now they're saying, how am I going to make that assignment? I would assign all of the dogs a unique number 1 to 300. I would place all of the numbers in a bin and mix thoroughly. The dogs associated with the first 100 numbered strong would receive glucosamine. The dogs that were associated with the next 100 numbers drawn would receive chondroitin. The remaining 100 dogs would be placed in the control group and would receive a placebo. Remember, the placebo has no effect. It just provides a baseline for comparison, so we know whether it's weather or some other outside factor such as age that's impacting joints. So rather than using a completely randomized design, one group of researchers proposes blocking. Now remember, blocking is stratification for experiments. So we want to control for and out something that we believe it's going to impact the study. We always block on the variable that we believe will have the greatest impact. And another group, so one group wants to block on the clinic, and the other group wants to block on breed of dog. How would you decide which one of these 2 variables to use as a blocking variable? Sometimes you can defend both, but remember, you always need to say that you're blocking based on the variable that you think will have the greatest impact. The purpose of blocking is to create homogeneous experimental groups. In other words, they're the same. By controlling for the variable that would have the greatest impact on the study. Once again, this is kind of definitional. It lets the reader know that I'm smart or I know something about this, but it doesn't get me my point. It just sets me up to be very successful. I believe that clinics across the country would have similar treatments, and therefore I would not block my clinic. And that makes sense. If you break your arm, you can go to probably 5 different hospitals and are going to treat it very, very similarly. Maybe not the exact same, but very similar. So I'm going to say the clinics are going to have similar treatment. Therefore, I'm not going to block my clinic. On the other hand, certain breeds of dogs are more susceptible to joint issues due to their size and genetics. Thus, I would block by breed because I believe breed of dog would have a greater impact on the study than a clinic would. It makes sense that size of dog would impact things. Okay, even if you don't know that there's the osteoarthritis situation or hip dysplasia, etc. And once again, one of the things I said earlier, the very beginning, or maybe the very first day on statistics, the more you know about the outside world, the easier this class becomes because the more connections you're able to make. And we know that certain breeds of dogs suffer from hip dysplasia, and generally speaking, it tends to be the larger dogs. All right, thank you.